On August 4, 2026, the Chinese government confirmed it had approved 8 new nuclear reactors. Not a proposal, not a study. 8 reactors across 4 provinces, worth an estimated 170 billion yuan, about $25 billion. Almost nobody outside the industry noticed. The approvals surfaced in routine stock exchange filings, the way a company might announce a new warehouse, because in China, that's what this has become, routine. 10 or more reactors approved in each of the last 4 years, and this batch simply opens year 5. Meanwhile, everywhere else, building a single reactor has become one of the slowest, most expensive things a country can attempt. Britain has spent a decade on one plant. America's latest project arrived 7 years late and tens of billions over budget. So how did the hardest thing a government can build turn, in one country, into something that resembles an assembly line? And notice what these 8 reactors actually are. The first batch of China's newest 5-year plan. A plan that for the first time in Chinese history puts nuclear fusion on the national priority list. Those 2 facts are the same story. By the end, you'll see why. Start with the numbers behind that batch. As of this spring, China had 60 reactors in commercial operation and another 36 under construction. Roughly 125 gigawatts of capacity either running or rising out of the ground. That construction fleet has been the largest in the world for 19 years straight. Here's a sharper way to see the shift. In 2025, global nuclear generation hit an all-time record, around 2,845 terawatt-hours. Strip China out of that total, though, and the rest of the world combined actually went backwards. Every kilowatt-hour of global growth came from one country. The United States still produces more nuclear power than anyone, about 826 terawatt-hours in 2025, nearly a fifth of America's electricity. Nuclear is only about 5% of China's power mix, but China has tripled its nuclear output in 10 years, growing roughly 11% annually, while the American fleet holds steady. One line is flat, the other is compounding. Lines like that eventually cross. So how did the country that imported its first commercial reactor technology end up outbuilding the country that invented the industry? The answer starts with the moment the whole industry stopped. China's program began by borrowing expertise. Its first big commercial plant, Daya Bay, went online in 1994, built on French designs with French engineers. For years, that's what the industry was: imported technology, absorbed one plant at a time. Then, in March 2011, an earthquake and tsunami struck Japan, and the Fukushima Daiichi accident froze nuclear power worldwide, including in China. Beijing halted all new approvals, projects sat idle, and the freeze left permanent damage. China went on to miss its own capacity targets twice: 58 gigawatts by 2020, then 70 gigawatts by 2025. In most countries, that's where the story ends. Nuclear becomes a political liability, the skilled workforce scatters, the supply chains dissolve. That's essentially what happened in the United States. An industry that once taught the world how to build reactors simply stopped practicing. China used the freeze differently. Somewhere in those quiet years, it made a single decision that explains everything happening today. It stopped treating each reactor as a one-off project, and it started treating one reactor as a product. The core of this story is almost boringly simple. Nuclear plants cost so much, partly because everyone gets treated like a prototype. New site, redesigned details, new contractors, a workforce that learned everything on the last job and then left. The real price of a reactor isn't steel and concrete, it's relearning. China attacked exactly that. It merged 2 competing domestic designs into one standardized machine, the Hualong One, a 3rd-generation pressurized water reactor with fully Chinese intellectual property, and committed to building it again and again and again. The first one, Fuqing Unit 5, took an ordinary, almost unglamorous amount of time. First concrete in 2015, commercial operation in early 2021. Nobody threw a parade. But that was never the point. The first unit is where you pay for the learning. Every unit after it is where the learning pays you back. Today, 10 Hualong One units are in commercial operation, with 37 more approved or under construction. Behind them sits a supply chain of nearly 6,000 companies that exist to build this one machine. The same components, from the same factories, on repeat. Chinese utilities are delivering reactors in roughly 5 to 6 years, at a reported cost under $3 billion each. Now compare. Britain's Hinkley Point C was priced at £18 billion when approved in 2016. The latest estimates run as high as $35 billion in 2015 prices, and it may not generate power until 2031. America's Vogtle plant finished 7 years late at around $35 billion for 2 reactors. Same technology category, same laws of physics, a completely different relationship with repetition. And once you see the approvals through that lens, they stop looking like policymaking. They look like a production schedule. Which brings us back to those 8 reactors, because the August batch reads less like an energy announcement and more like a factory's order book. Look at what's actually in it. Zhejiang and Guangdong will host the world's first Hualong One version 2.0 units, each rated around 1,217 megawatts. Not a clean sheet redesign, an upgrade package. The reactor now gets version numbers, like a phone. Liaoning gets a brand new site, Zhuanghe, running the standard, proven Hualong One, the volume model. And then there's Shandong. The new Liang plant will host 2 Guohe 1 units, each one 1,543 megawatts, the largest reactors in the national lineup. Officials call this the start of that design's large-scale, standardized construction. When all 6 planned Liang units are complete, it becomes the biggest nuclear power station in China. So inside one routine approval round, 3 things happen at once. A flagship design gets its mid-cycle upgrade. A proven design is copied to a new site, and a second design ramps from prototype toward mass production. 4 provinces, 3 state giants, private capital alongside them. Roughly $25 billion. A single Hualong One generates about 10 billion kilowatt-hours a year, the consumption of a city of 1 million people, and the Guohe units are bigger still. This batch alone will serve on the order of 8 million homes. And the most telling detail? This was just the first batch of the year. But step back, and an honest question appears. China already builds more solar and wind than the rest of the world combined. Why does it need a reactor factory on top of that? Because China has a demand problem, the kind every industrial economy secretly wants. Electricity consumption keeps climbing, driven by the industries China dominates: manufacturing, electric vehicles, and now vast AI data centers that cannot tolerate a single flicker. Solar and wind are excellent, but they sleep. The sun sets, the wind drops. A grid built only on intermittency eventually fails at the worst possible moment. Coal has always filled that gap, and in the first half of 2026, something happened there that barely made headlines. Coal's share of Chinese electricity generation fell below 50% for the first time. That's the slot nuclear is built to take. Clean, constant, 24-hour power. The foundation underneath the renewable buildout. Beijing's official target, 110 gigawatts of operating nuclear capacity by 2030, up from 62.5 at the end of last year. Industry projections point to 200 gigawatts by 2035, and a June 2026 analysis by Gavikal concluded that, on its current trajectory, China overtakes the United States as the world's largest nuclear operator within 5 years. Look at the August batch through that frame, and it stops being news. The 5-year plan needs a steady flow of approvals, roughly 10 reactors a year, just to stay on schedule. These 8 weren't an event, they were an installment. Now, this is where a story like this usually becomes a victory lap. It shouldn't, because the machine has real cracks, and one of them just produced a result almost nobody predicted. First, the record. China has missed its last 2 capacity targets. Approval isn't construction, construction isn't operation. And at roughly 5% of the grid, nuclear is still a minority of Chinese power, no matter how fast it compounds. Then there's the twist, and it happened on a single construction site on Hainan Island. The global industry has convinced itself that the future of nuclear is small modular reactors, factory-built, shipped to site like appliances. China has one of those too, the Hualong One, the world's first commercial, land-based SMR. First concrete in July 2021, designed for a 58-month build. It was supposed to prove that reactors could be truly mass-produced. As of this summer, it still hasn't reached first criticality, months past its deadline. And here's the part nobody predicted. A full-size reactor at the very same site, begun just months after it, got there first, reaching criticality in July 2026. The futuristic small reactor slipped. The boring, repetitive, full-scale machine won the race. That's a genuinely useful result, because it sharpens what the assembly line actually is. China cannot mass-produce anything it wants. What it can do, maybe better than anyone, is repeat a proven big design until the costs fall out of it. Discipline, not magic. And that discipline is exactly what makes the next chapter significant, because the machine is now being aimed somewhere new. The first direction is outward. Hualong One units already operate in Pakistan, Kanup 2 and 3 in Karachi, with another exported unit, Chashma 5, under construction since 2023. Chinese firms are bidding into Saudi Arabia and courting Southeast Asia, reportedly coming in far below competitors on price. Every Western cost overrun works as a silent advertisement in those tenders. The country that once imported French reactors now sells its own, the same path it took in solar panels, batteries, and electric vehicles. Build at home, learn at scale, export the surplus. The second direction is deeper. On the Shandong coast sits Shidao Bay, a high-temperature, gas-cooled design that became the world's first commercially operating 4th-generation reactor in December 2023. 2 experimental fast reactors are rising at Xiapu, designed to stretch nuclear fuel dramatically further and consume what conventional reactors leave behind. While the assembly line stamps out the present, the prototypes of the next product line are already running. And the third direction is where this story stops being about reactors at all. Among the 15th 5-year plan's 109 major engineering projects listed invented alongside semiconductors and artificial intelligence, sits a phrase worth pausing on: controlled nuclear fusion. As industrial policy, not as science. The hardware is already standing in Hefei. There, engineers are assembling BEST, the burning plasma experimental superconducting tokamak, with the main machine scheduled for completion by the end of 2027. China's existing machines have already run plasmas hotter than the core of the sun. In 2025, the HL3 tokamak pushed its ions to 120 million degrees Celsius and its electrons to 100-acre campus, called Craft, built for one purpose: to industrialize the manufacturing of fusion components, the magnets, the alloys, the power systems. Not to discover fusion, to be ready to build it at scale the day it works. The money matches. China spends an estimated $1.5 billion a year on fusion, roughly double the US federal budget, plus $2.8 billion on a fusion-fission hybrid called Xinghuo, targeting 2031 for its first phase. The official roadmap points to a pilot fusion reactor around 2035 and a demonstration plant near 2045. Will they hit those dates? Nobody knows, including them. Fusion has been 20 years away for 60 years, and that track record deserves real skepticism. But look past the dates at what's actually being built. Not just experiments, a supply chain in waiting. The same machine that turned the Hualong One from a delayed prototype into 10 operating reactors is now being assembled underneath the fusion program. Fission, it turns out, may have been the rehearsal, which brings us back to that routine filing from August 4th. 8 reactors, 4 provinces, $25 billion. Announced like a warehouse opening. There was never a secret technology here, and never any magic. The assembly line is a decision, made in the shadow of Fukushima, while the rest of the world walked away. Pick one machine. Keep the workforce permanently employed. Anchor 6,000 companies to a single repeatable design. Then, never stop. 10 approvals a year, 5-year builds, version numbers on reactors. Nuclear power handled the way the rest of the world handles consumer electronics. And the reason it matters reaches far beyond China. For most of the last century, geopolitical leverage belonged to whoever controlled energy: the oil states, the shipping lanes, the choke points. The next century's version of that prize isn't fuel, it's power, literal electricity, in staggering quantities, for AI, for industry, for everything a modern economy does. And leverage will tend to flow to whoever can manufacture power. Right now, that capability lives overwhelmingly in one country, a country on track to operate the largest nuclear fleet on Earth within 5 years, already exporting its reactors, and already rehearsing for fusion, the long-promised endgame of energy itself. So the August 4th approvals were never really a question about whether China can build 8 reactors. The assembly line answered that years ago. The open question is what happens to everyone else now that the machine doesn't turn off.